Hi guys, I was quite a bit surprised when below my kind of one of my very first videos related to code and brain fuck programming language interpreter, I found a commentary, like, and Planet Hero couldn't get the loops work, and we've talked a bit here, and it turned out that probably so he had some issues with memory addressing as well as memory reference, and I didn't really understand from his answer. Does he really understand what is the difference between the variables and the pointers? And Plant Hero, please, sorry if I'm insulting you by saying that you don't understand the difference. I didn't really mean to do that, so just please don't hate me. I just really don't understand whether you actually do understand this difference or not. And that's actually the reason I've decided to make this little video about what are the pointers in C and how to make use of them. So, well, Planet Hero, you have inspired me to make this video, and probably, well, I'm actually making this for you. And again, if you really know this stuff already, I'm really sorry for I didn't mean to insult you, just to make the things clear. For when we had our conversation, I had a kind of feeling that you don't really understand what happens here, or well, your answers told me that. So just if you already know this, please sorry. Okay, and now I'd like actually to write a little C program in order to demonstrate what are the pointers and how to make kind of use of them. And also I'll give you a little illustration over here in order to kind of show what happens visually when we're dealing with the pointers. Okay, so let's create a simple C program here. I need to include stdio in .h in order to be able to print things to the screen, and the main function, and return 0. Okay, and the first thing I'm about to do is just to create a variable called a save. And now I just want to print print the value of that particular variable to the screen. So we say a, and we want the decimal format specifier here, like this, and maybe the new line. Okay, and it should give us 0. Okay, so a is 0. So if we kind of change the value of this variable, say a is equal to, well, say 8, save, then it changes. Well, this is quite pretty self-explanatory as well as clear, I hope, for everybody. And now when we're talking about the pointers, it's a thing that confuses many guys who has just started learning C. So you could have made this sort of declaration. So int pointer ptr, like this. So this little star here, so it defines the type of pointer to an integer variable, and the pointer is actually the address of the particular variable. Well, so we have two kind of sort of things. First, we have the reference of memory cell that is binded to the a variable, and the reference is 8. And also this this a variable has an address. And here I got this little schema here. So we have the memory address and the memory reference. So by default, well, say here are some addresses. And when we declare a variable, what happens? Well, basically, the address is being associated with some sort of a kind of variable name. Yeah. So when we say variable a, that computer understands that we are talking about the memory, well, hexadecimal 2 in this case. So this is known as the memory address. And when we talk about the memory reference, it's actually the value that is available at this particular memory address. So in case if we have defined the memory, we have defined the variable, so some address in physical memory has been occupied by this, and we can also change the reference. Well, by default, if we just kind of define the variable in C globally, it would be equal to 0. That's kind of standard for C. Well, if it's not globally declared, that it may contain any possible value. It just doesn't matter really. And now, what we can do with the pointers, how we can make use of them, is actually we can assign the value of the variable address to the pointer. So this little line here, I'll just code it in my file, but just before that, so after this operation, the pointer variable is actually storing the address where the variable a is actually sitting at. So let me just demonstrate you this quickly. Okay, and now I just say that PTR pointer. So it's all we know that this PTR variable is the type of int pointer, like this. So if we just print this like so, the compiler would give us a warning. Just let me demonstrate this. It says the assignment makes pointer from integer without a cast. That's actually wrong. So what we have to do here, we have to make the PTR equal to the address of the a variable. So this and symbol here, it stands to represent the address of the a variable, and now it compiles without, oh, it still does. Oh, I just didn't save it. Okay. And now it compiles without warnings. And now if we want just to kind of print, if we want to print our pointer value, it would give us probably give us a warning, I believe, but still, nevertheless. Okay, decimal like this, and PTR. It will probably give us a warning, yeah, but just doesn't matter. And here we have a big number, and this big number, well, this is in decimal, not in hexadecimal, but doesn't matter really. So this is like this one. So it's the address. So the address of the a variable is 6295624 and so on. So it's kind of the address. So bear that in mind, please. Okay, and now what we actually can do. So if we just say want to do things like a equals a plus 1, well, in this case the value of a would be 9, and that's well, quite expectable. Okay, but also what a tricky thing about pointers, that if we say if we would be manipulating pointer like this without a star here, then in this case we're talking about the memory address. But if we want to reference the particular memory address, so by saying reference, I mean we are referencing this value or this value that has been already adjusted. And in this case we want to say pointer like star to PTR. Well, and if here we say equals say okay, like 1 2 3, well, in this case the a would have the value of 1 2 3 regardless of how many operations has been performed here. Let me just demonstrate you this. As you can see, so now a is equal to 1 2 3, so no matter what we did here. Well, this happened because actually this pointer variable is the address of the a variable, so it's like exactly the same address. And if we just put this little star here, and then we like kind of assign some value, so it's equal as if we would say just a equals to 1 2 3. So these lines are absolutely equal from the perspective of what kind of output are we supposed to can get. And this is quite useful when we say we can also pass the pointer to the variable like this to the function, and the function will actually be performing some sort of kind of changes to the variable and would return it. If we don't do this, the function would just copy the variable we've passed to this, and so the original value of the variable would actually remain the same. So if we want to change something, we have to pass the address of the variable, and in this case we actually get the result we are expecting. Okay, but this wasn't really the point, like of our particular of our conversation here, and let me just to dive a little bit deeper. And now I just delete this stuff, doesn't really need it anymore, and let me show you another little trick here. So if we say have an array, well, let's call this array of, well, say 5 elements, and here, well, let me just have a little for loop. Okay, I is less than 5 and I plus plus. Okay, and I want just to printf. I want to printf array I, and the expected result is 5 zeros because this array is global. Okay, what happens? Okay, oh, just didn't specify. Okay, let's say array I and decimal here. Okay, and just maybe add a new line to make it a bit more clear. Say, okay, so we have all the elements of the array are equal to 0. If, say, we here initialize the array at the very beginning, say 0, 1, 2, 3, 4, like this, then we actually have these values. And please note one little detail here. So in order to reference the particular element of the array, we're using this sort of constant, and this is, well, it's quite convenient from the C perspective, so it's kind of feature that C programming language gives us. But basically, what is the main point about the array? So it might be observed as some sort of a collection of pointers. So you know, like this is memory address, and this is another memory address, and another, and so on. So just in case to show you how can we do this, not using the notation for arrays, but using the notation we've used in the previous example. So if it just would be well, let me just demonstrate you this. So in case if I just print array like this, he would give me a warning apparently, and also the address of the very first element in the array like this. So yes, he gives me just 5 times the address of the first element here. Well, if here I would make a little star, then it would give me the value of 0 like this. Okay, and if after this I will make array plus I, then he gives me exactly the same result. And this guys, believe me, this is like kind of the most important thing here. So it's well, you know, like when you just well, just make a comments here. Let me maximize this. So when you say like kind of array and I, like element index, doesn't matter. Well, what really happens at the low level, at the compiler level, or if you just ever try to code in assembly, you definitely know this. For assembly, doesn't really kind of have this sort of constructs. Well, in some cases it does, but it's probably not the same behavior. Like if you've been using NASM or something like that. Well, so just to make it clear, so. This is a list of pointers. So we have the pointer to the very first element in the array. So this just kind of list of pointers, so 5 pointers here. So that we had only one pointer like in PDR, yeah, and here we have actually 5 pointers here. And and each time we add to the pointer the offset. So this I is actually the offset. Well, in this particular declaration, the I, we observe this as like, okay, this is index for the array. I say I want the first element, the second, the third, and so on. But that's kind of more a high level understanding of things. But in the low level understanding, it's really quite important to understand that this I over here is not the index, it's actually the offset. So we take the address of the very first element and we add the offset, and this is it. And in order to have and in order to reference the particular kind of index, like we say this in a higher level terms, then we have to use this star here. So please kind of try to understand that this one representation and this one are absolutely the same. And here we have come to the particular thing that we were discussing below this YouTube video, and now let me show you some stuff about the strings. So like the characters are actually the integers encoded as the ASCII using the ASCII encoding. And so we also could have defined it like so. So here we'd say we have H, here would have A, and then L, okay, and then L, and then O, and finally the 0 terminating character. Well, if you're not specifying the string, well, that basically this 0 terminating the character, okay, O here, not 0. Okay, is actually needed. So when you kind of define the string, the compiler does this automatically for you. Okay, and now I don't really need this anymore. Well, actually I can use this also. So here I want to print the character, and if I did everything correctly, he has to print the hello string. Okay, he doesn't print the hello string. Yes, because okay, well, it doesn't. Well, because why? Maybe. Well, sorry guys, just a moment. I didn't test this actually before recording this video. Okay, like this. So when we're dealing with kind of strings, well, what we have to do is actually to take this braces around. So here we reference, so it's kind of the more precise way of defining things. So as you could see that when we were dealing the integers, it was kind of just fine, but when we're dealing the characters, the things can get a bit different, and so we have to add this sort of braces here. And here we have this hello, and if we just remove the new line, and remove this stuff away from here and this quotes, then we have actually hello printed like this. And also we can actually not using even the printf but the put char, and don't need this stuff anymore, and basically okay, and we have hello again over here. So and this is, well, like some part of how the printf is actually implemented. But what printf actually does allow us, we don't really need this for loop. We can say simply printf, and then we specify the string output, and this would already do the things automatically for you. And here we just say the array, and in this case the array is the pointer to the very first element of the entire array, so the pointing to this particular element. So here, if I did everything correctly, he has to play. Okay, it doesn't. Okay, format expects argument of char pointer, but argument has, oh, okay, it has the type int pointer. Okay, let me just maybe just make it okay. Maybe like make, oh, array. Okay, so still something wrong. Okay, pointer express elements, access elements in the array initializer. Okay, let me just kick this out now. Okay, now this is it. So well, it just this string specifier doesn't work with the if we're dealing with the integer type. Well, just how the printf is actually made, but still the gist doesn't change from this. And as far as this is not the most ever convenient way of defining the string, so it's kind of too many characters. The things that is available for us in C, we can say simply hello like this and have exactly the same result, just this hello here. And even more, if we just define the string in this manner using the double quotes, basically we don't even need to specify the size of the array. It would allocate this for us statically, just automatically, like this. So that's what the compiler does. So here we have this kind of our little hello. And now I'm actually at last, last but not least, I've come to the very gist of our conversation over here. So here's what I was actually supposed to kind of show. So what happens? What happens in brainfuck interpreters? So say this string is the source code. So what we can add some brainfuck stuff here, like it's complete nonsense now, but just to give you an example. So say the commentaries and the program, something like that. Okay, let maybe just to give it a bit more sense, I just make it look like at least something like this and like this. So to make it a bit more look like a real brainfuck, so some sort of multiplication is done here, but it's not about the brainfuck compiler or interpreter now, but just about the instruction pointer. And as you remember from the example where we had the for loop, we did the I variable was represented the offset. So offset was 1, 2, then offset was 2, and that offset was 3, 4, and so on. So we just did kind of add that sort of set. And now what we can do here, we can define char pointer to instruction and like this. Well, and actually we can already initialize this, and it equals to array. And let me see if this just compiles. Well, I hope it does. Okay, and now what we want to do, we make this little while loop. So we say while pointer to instruction, and this means, so as far as the pointer to instruction, so it points to H, to E, to L, to O, and so on, until it points to something that is not 0, which is, and the 0 is not seen, but we kind of have some sort of 0 terminating string here. It's not visible, but so this, when you define the string, you don't have to print this, but if you actually would see the assembled code, that you'll see that there is a little kind of 0 terminating character at the very end of the string. So we say while the instruction points to the actual character, not to the 0 pointer. So as far as it would be pointing to the 0 terminating character, it would actually break out the while loop. So while we are kind of within the string, what we want to do, we actually want to well, let's put char and pointer to instruction in order to reference instruction. So this program would actually hand for the while loop wouldn't ever exit. And let me just demonstrate. You see, he's stuck at the H here. But if we here we just say instruction plus plus, then in this case, actually, we have the entire string, and this is like if well, x probably exactly the same as the printf. And now finally I've come to the very gist. So well, here we have two lines, but if we want just to use the only line, then we can say it like this: we add this plus plus over here and delete this line and save, and actually run this again, and we have absolutely the same output here. Well, Planet Hero, if you're watching this, like, this is the explanation of how we had this. So we did have like kind of this construct, but it's actually kind of two lines, and what we came for is actually this one line. And here we can go even further. We don't have, well, it's not often that convenient to increment the pointer, so instruction pointer, by one within the kind of this loop. So what we can do here also, we can actually increment it over here. So in this case we get well, not absolutely the same result. Well, it's actually first the increment well, like well, it's not, we don't see this h for he incremented the first element before the putchar function has been invoked, but nevertheless this is kind of like what we have here. And now just what you were also asking about. So what happens is we put this two pluses to the left, then in this case you see we are not kind of adjusting the pointer location. We're not working with the instruction pointer with the offset anymore. Instead we're changing the values of the corresponding characters here. So that's the answer for your question. Like you said, I don't remember where exactly. Just so here you were wondering what happens if you put these two pluses just before the source. So well, actually this is a disaster that is going to happen that way. Well, even though it compiles and runs, but it's not the expected result. So regardless of the brainfuck stuff over there, it's about like how to deal with pointers. So let me just compile run again. So here we have this, well, no h, but still it's quite, I hope this is quite self-explanatory. And now, well, let me just very briefly to show you, as far as we actually haven't taken the time, just okay, let me show you the particular example. Okay, it's probably be faster to take it from here. So full source code. So what happens, well, I hope that this part is quite self-explanatory. So well, but let me just explain this one more time. So what I've just explained, so we increment the memory pointer, so, or the address basically, and here we increment the memory reference, what I've just shown you. So what's the difference between if you have this pluses to the right and to the left, in case when we are working with the pointers. In case if this is not a pointer, that this is known as post increment and pre increment. And it also so the difference that here we actually first we reference the variable and then we add value to this. And in this case, if this is not a pointer but just the integer itself, then first we increment and then we reference, and that's the difference between those two. And here when we're dealing with loops, actually, so what happens, this code actually checks it counts the number of corresponding square brackets, and each time he founds the corresponding bracket, he increments the loop variable that stores it. And this is needed in order to have the exactly the same number of matching brackets. It's that's the algorithm that is involved in text editors. So you see, if you just click to this one brace, and he highlights the other here. He highlights this, not this one, but this one though. So that's because he calculates exactly that here he has the two curly braces, and here he has also two, and he knows that this one is actually matching this one. So exactly the same thing happens actually in this code. And what we have to do in it's about the matter of brain fuck rules. We have to adjust the increment, like instruction pointer. Here we increment, so here we're moving the instruction pointer. So from here, say the cursor is the instruction pointer, so we are starting to move this to the right like this. So this is what this star source plus plus string does. Well, so, and in case of the closing square bracket, we do exactly the same but in the reverse order. So we go like here, 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 and here, and so on. Well, okay. Well, Planet Hero, if you've been watching this video, well, I hope it now makes a bit clear. Well, if it isn't, you can still mail me your code and the particular sort of errors. So if you have any errors here, like, well, you just grab this, copy and paste to the mail, and I'll see what's going on. So if I just really did understand you wrong, then probably, well, it's I'm sorry if it's not the case. And again, I didn't ever mean to insult you. I just wanted to make the things clear. And I also think that your question is just really brilliant, because it actually kind of takes the very important topic in the low-level stuff, and without understanding of these pointers and arrays and all this stuff, it's not really much kind of to do in C or assembly. So it's kind of very important stuff. Okay, well guys, I hope this was kind of interesting or useful for you, and I'm waiting for your commentaries in the feedbacks, and take care.